Guys, we have chosen house price prediction analysis our final project title. So we have chosen a comprehensive data-driven approach. We are assignment group one, and I am Sachar Angoli, and here are our teammates. And the next slides will be explained by our teammate Sai Prakash Kodela. Over to you.
Yeah, thank you, Charan. So coming to our project, so at first we need to know about the how the background process is going on. So the real estate pricing dynamics currently are essential to the global economy, so influencing decision across multiple sectors. So accurate price forecasting is vital for financial institutions, real estate brokers, investors, and homeowners. So these stakeholders depends on a reliable data to make informed decision about the financing, investing, and the managing properties and the transaction. So understanding these dynamics allows for effective risk management and maximizing of investment opportunities, ensuring the economics stability and growth. So the objective of this project is majorly focused on creating a predictive model that leverage the machine learning algorithms and historical data to estimate the home values by analyzing various property characteristics. So this model aims to predict the property price with accuracy. This initial seek to enhance the decision making stakeholders in the real estate market by providing the more precise and the reliable property valuation. So can you move to the next slide? So, so coming to the introduction, so majorly this project is significance. So by seller and buyer, real estate agents, financing institutions, investor. So here the seller and buyer ensure the fair market pricing, helping seller to avoid undervaluation and the buyers prevent the overpayments. So and the coming to the real estate agents here ensure the accuracy of evidence to the clients and more efficient transaction and increase the customer satisfaction. And coming to the financial institutions which aids in property appraisal for mortgage, reducing the risk of loan defaults. So and coming to the investors, this investor provides insight into potential returns, assisting in a effective real estate portfolio management. So can you move to the next slide? So here, at first, we need to know about the data collection. So the project which utilize the data from the Kaggle competition, so which provide the comprehensive data sets divided into training and testing sets. So these data sets includes the critical attributes such as the year built, lot size, condition of the home, and the location. So the data sourced from the Kaggle is generally reliable and has undergone preliminary cleaning. So, however, the additional preprocessing might be necessary to refine the data futurely and particularly to manage any outliers or correct distributors in the data sets. So, can you go to the next slide? So here we need to know how we're gonna pre-processing and clean the data. So following the initial pre-processing of the data sets. So at first the data integrity check we need to know. So where carried out to confirm the quality and readiness of the data for modeling. So these check ensure the absence of any residual missing data or misencoding categories. So these pre-processing efforts were instrumental in preparing the data sets so for the modeling phase and significantly enhancing the model performance and by ensuring the high data quality, this step aid in achieving more accurate and predictive outcomes and optimizing the data sets for effective use in modeling. So coming to the next slide, explained by one of other friend.
Thank you, Prakash. In this slide, we are going to see some of the steps followed for the pre-processing and data cleaning. On the right-hand side of the slide, we are able to see some of the part of the code, and there are some of the 6 key points which are able to coming from this part of the code. In this code, we are able to setting a threshold for dropping a column, and we are coming to know the identifying the columns to be dropped, and the dropping identifying columns from train and the test data will be also done in this code. And the fourth point is we are coming to know the filling missing numeric data with median values. And we also defining the columns to fill within none. And also we also come to know the filling specific column within none. And going to the next slide. In this slide, we are going to see about the data analysis. In these scatter plots, each off-diagonal plot show the relation between two variables. For example, the sales price versus overall 12. These plots suggest a positive correlation, meaning as the overall quality of a house increases, the sale price also tends to be increases. And the third point is the sale price versus the live area price. There is also a visible positive correlation here indicating the larger living areas are associated with higher sales price. And the interpretation of scatter plots, the linear relationships indicates a strong correlationship between the variables. For the instance, the scatter plot of the sales price and the live area shows a clear upward trend and highlight a strong correlation. And clustered or non-linear patterns can indicate a more complex relation that may require further analysis of different types of modeling approach. Yeah, in the next slide, we are to able to see some of the graphs of these pictures which I have explained in the above slide. And the next slide will be explained by following teammates.
Yeah, here is the future engineering of the house. Reduction of dimensionality is the future engineering also involved reducing the dimensionality of the data through techniques like principal component analysis to improve model efficiency and manageability, and ensuring that the future were appropriately encoded and scaled made the data suitable for various machine learning algorithms, enhancing the versatility of the modeling phase. Next, here is uh, the new future of the square footage, like uh, it first floor, second floor, and total basement. This process helps in it also potential enhances the model's ability to learn by providing a more comprehensive metric that might correlate more directly with the target variable, like the sale price of the house. Uh, for the new future of the house, we are using this formula. Here, the trained data set is the data frame where we have stored the stored the chosen data set, that is trained data set of total square footage equals to trained data first floor square footage plus trained data second floor square footage plus untrained data total basement. And the test data is the data frame by which test the newly created house future. Next.
Yeah, thank you, Joarika. So let's get into the model development, which is the main part of the final project. So coming to the algorithm benchmarking, several algorithms were tested to see which one made the best predictions for this particular job. So the random forest regressor emerged as a strong contender for this project. Also, the crash validation strategy, it is a strong cross validation strategy was used to test the model success on different groups of data, which increased confidence in ability to be used in other situations as well. So coming to the importing necessary libraries and functions. So by importing the required libraries and functions, you can divide the data into training and evaluation sets. So the regression model that is used to random forest regressor. So the mean squared error and the R2 score are performance measures for the model. So they are imported but not used in the code snippet shown. Getting the data ready. So we are preparing the data ready. So X is made by taking out the goal variable sales price and from train data and choosing only columns that are numbers, whereas train data is where we loaded our chosen data set. So the goal variable is Y, and which stands for the sale price. So the data is split into two sets, which is training and validation. Validation gets 20% of the data. So the another part of the model development is the model initialization and training, where up setting up the model and training to make sure the model can be used again and again. So it is set up with 100 trees in estimators, whereas is equal to 100. So and the random is random state, the training data, so X train and Y train are used to teach the model. So figuring out the showing how important the future is. So the alarm model is used to get the future importance, which shows how important each input future is to accuracy of the model's predictions. So the levels of value are sorted and a horizontal bar chart is made to show how important each feature is. So the cross validation, coming to the cross validation, the model is put through cross validation on the training set, which is split into 5 parts. Uh, Whereas we have already mentioned like CV equal to 5 to see how well it works, then it's not given the training data. So to see how well the model works on the average across different groups, cross validation scores and the mean are printed. So coming to the results, so we have discussed the graphs sorts the traits by how well they can be predict the sale price based on the graph in which we have I'm going to show you the graph in the next slide. So coming to the features, the top features overall the quality of the which is the quality of the materials and the finish as whole. So the size of the living space around ground and the total SF, which is the total square footage of the basement, which is used to develop the feature house, are some of the most important features. So the size of the quality of the materials used in the building, like big but figuring out how much it costs, and not as important features. Some features such as pool area, basement half bath, and miscellaneous values have very low important scores, which means they don't have much of an effect on the model results. So let me show the results here. So here is the result I have obtained from the chosen dataset by using the code. So the overall quality is high for importance. So the next slides will be explained by one of our teammates. Thank you.
So coming to the cross-validation scores explanation, the cross-validation scores represent the model's performance based on the different subsets of the training data. Here are the scores given for the particular subsets. Each score reflects the R-square value of the different fold, indicating the proportion of the variance of the target variable that is predictable from the features. The mean CV score given is 0.83, which is the average of the cross-validation scores, provides a single number that summarizes the model performance across all the folds. An average R square around 0.83 suggests a good fit, where the model explains about 83.4% of the variability in the target variable across the different subsets. So coming to the next slide. Coming to the training curve, here you see the training score starts very high with small training sizes, then increases slightly with more data. The cross-validation score begins high but decreases significantly as more data is used, indicating better generalization. The gap between training and cross-validation scores narrows with the increasing data size, suggesting the model is not overfitting. Both curves start to plateau, especially the cross-validation scores, indicating that adding more data beyond a certain point might not significantly improve the data performance. Coming to the interpretation, this analysis helps in understanding the trade-offs between training on more data versus benefit in model performance, guiding decisions on the data collection and model complexity. Okay, just go to the next slide. Here you can actually see the learning curve. The red indicates the training score and the green indicates the cross-validation score. Below is the training set size, starting from 0 to all the way to 1200. And coming to the MSE, mean squared error. This means the amount of error in the statistical models. It assesses the average square difference between the observed and predicted values. When the model has no error, the MSE equals to 0. As model error increases, the value increases, which you can see here. The MSE is also known as the mean square deviant, MSD, but we use MSE here. So the next slides will be explained by one of my teammates. Thank you.
Hello everyone. Coming to the conclusion, we can see the model performance. The random forest regression model shows a promising ability to predict house prices as evidenced by good cross-validation scores with a mean CV score of approximately 0.834. This suggests that the model can explain about 83.4% of the variance in the target variable across different data subsets. The learning curves demonstrate that the model benefits from increasing the amount of training data as the cross-validation error decreases and the curves start to plateau, indicating a stable performance. Next slide. Feature importance. The analysis of feature importance highlighting that overall material and finish quality, GR, LV area, above ground living area in square feet, and total SFT, total square feet including the basement, first floor, and the second floor are critical predictors of house prices. This says that both the quality of the construction and the size of the house significant impact in the price. Lesser important features such as pool area and mixed well having minimum impact on the models predictions, indicating that these areas could potentially be exclude the future modeling efforts of simplify the model without losing predictive power. Data analysis and learning curve. The learning curve analysis reveals that while the model initially overfits with low MSE on a training data and high MSE on a validation data, it generalizes better as more data is issued. This is indicating by the converging of training and validation errors as the training and size increases. The variability in model performance, as shown by the shaded area around the learning curves line, decrease with the more data, suggests increasing stability in model predictions. And coming to the next slide, my team is going to explain.
Hello everyone. Thank you, Srinu. While coming into the third conclusion, that is data analysis and learning curve. The examination of learning curves uncovers an interesting trend in the model's behavior over varying amounts of training data. Initially, the model tends to overfit, means it performs exceptionally well on the training data, but struggles to generalize to unseen data, resulting in higher mean squared error, that is nothing but MSE, on the validation set. However, as more data is incorporated into the training process, the model starts to generalize better, as indicated by a convergence to the MSE values for both training and validation sets. Furthermore, the shaded areas surrounding the learning curve lines, which represent the variability in model performance, decrease as more data is utilized. This reduction in variability suggests that the model predictions become more consistent and stable with the inclusion of additional data points, indicating a heightened reliability in its performance across different subsets of the data sets. And while coming into the next slide, the next slide is the future scope. Here, to enhance future engineering, delve into crafting new features capable of capturing intricate interactions and nonlinear relationships that influence house prices, and this could involve exploring combinations of existing features or transforming variables to better represent underlying patterns. And by coming into the second one, for advanced modeling techniques, consider experimenting with sophisticated machine learning algorithms like gradient boosting machines, nothing but GBMS, or delving into deep learning models. By doing so, you can access potential enhancements in predictive performance compared to conventional methods. And while coming to the third one, to optimize model parameters, employ strategies such as grid search or random search to fine-tune the hyperparameters of the current model or any alternative models utilized. This systematic approach helps identifying the optimal configuration for maximizing model performance and refining the predictive accuracy. Thank you.